All right. We are going to talk about PHP today. We had a little bit of discussion about it the week before spring break. I hope you all had a good spring break and you got work done or relaxed or maybe a little of both. That's kind of what I did. Although I did a lot of work, I caught up on grading because I kind of fell behind. At any rate, onward and upward to talk about PHP. PHP is a server-side technology, and what that means is, in our diagram, where we have the client connected to the internet, which in turn is connected to a web server, the clients make requests, and the servers respond to them. They make a response. And if it's a plain old HTML, all the web server does is grab the file and send it on its way. But with PHP, PHP scripts need to be processed. So the web server retrieves them when a request is made for them and processes them. And produces as output HTML, which then is sent to the client as a response. So you start with PHP, the server processes it, and produces HTML. It gets delivered to the client. So we looked at a quick example last time, and let's look at the same example today, and then we'll look at a couple other examples that I hope can make more concrete this notion. First example we had was just a very simple one that I think squared the numbers from 1 to 100 or something like that. Now, I have this on the desktop. I can't do like you've done with all your HTML files so far and just double click it and open it up in the browser. I can't do that because PHP is not a web page, not a finished web page. It is the instructions to produce a web page. Therefore, these instructions need processed by a web server to get the job done. So I must put them in a position in the proper directory on a machine that has a web server and request them through the web server. Now I have videos about XAMPP or XAMPP, I'm not sure how to pronounce it. I have examples about that in Canvas, so take the time and read that. That's a good way to get a web server installed if you do not already have a web server installed on your machine. How do you tell if you have a web server installed on your machine? Open up a browser and type in localhost and the address. Localhost means the web server on this machine here that we're running. So if you go here, type in localhost, and you get something, you have a web server installed. If you get nothing, then you do not have a web server installed. Now, my particular web server is IIS, which is Microsoft's Internet Information Services. And IIS is, for IIS, the default location for the files, where I'm going to put my files, is in the folder C inetpub www. So for example, if you were working on your assignments here, all the machines on campus are set up that way. And if you have IIS installed on your machine, that's how it would be set up. If you install XAMPP or some other kind of web server, then your mileage may vary, and the documentation should tell you where your files need to be. And if it doesn't, you can't figure out where those files are supposed to be, let me know, and I can give you a hand in finding where those files are supposed to be. So I'm going to clear out everything that's in there now. These are just some sort of default files. And I'm going to put my files in here. So I'm going to put all these files in here. And again, there's permission, so I have to say, yeah, that's okay. So it puts them in here. So now it's in the what's called the web server's root. And what you do to request files that are in the web server's root is you type in the server name. Which is localhost. And you type in the name of the file. So first.php. If it was in a subfolder, you'd type in localhost /subfolder/first.php. If the file's name is index.php, I don't think you need to type anything in. I think it will just open up if you type in localhost. But anyhow. All right, this page is made via PHP. It's the numbers from 1 to 100 and the squared values. Now, we talked about last time how PHP is a mix of plain old HTML and PHP code. So when we open up this PHP script, we'll see that it is a mix of HTML and PHP code. Everything outside of these directives is sort of looks like a tag, but not really a tag, is plain old HTML. The web server doesn't do anything to that other than deliver it to the client. The stuff inside these directives is where PHP does its job and actually does processing of the code to produce some output. And then that output is going to be HTML, and that will get sent to the client. Now, here's what I mean by you have to run it through a server. We ran it through a web server by typing in localhost first.php. And if we look, we have plain old HTML on the end. We have a table with a bunch of TRs and TDs. That's different than the PHP code, because the PHP code, remember, is the recipe. It's the instructions to produce the web page. When the web server processes it, it produces the output. So let's look at what this particular PHP page does. All right. And let's look at some of the differences between this and other programming languages. All right. First of all, you'll see the word print. A synonym for print is echo. Print and echo mean the same thing. What that means is it means send this code to the client. And in this case, what I'm sending to the client is a table tag. And then down here, I'm sending the end table tag. And between here and here, I'm producing all the rows and table cells. So I'm printing a TR that contains a heading for number and a heading for the word squared and an NTR. So that gets sent to the client as is. There's a table tag that got sent to the client. Here's the first table row. So far, pretty simple, where it says echo or print, whatever is in quotes is sent to the browser. Now here we have a loop statement, and you should be familiar with loop statements. What this does is this is going to execute the body of this loop a certain number of times. It's going to execute these two instructions, 14 and 15. And in this case, it's going to do it 100 times, because I start n off at 1, I'm going to repeat this loop as long as n is less than or equal to 100, and each time through the loop, I'm adding 1 to n. So that's what this means. Start it off at n equals 1. Repeat this loop as long as this is true, as long as n is less than or equal to 100. And then each time through the loop, we're incrementing by 1. Now notice this might look a little different from JavaScript and other programming languages that you've used. The variables begin with a $sign. So for simplicity, I'm going to say n, just so I don't have to say $n, all right? But the variable n is actually $n, okay? So n takes the value of 1 through 100. So this loop is going to execute 100 times. Line 14 says make s equal to n times n. So we're squaring n here. Now, this is just a calculation. We've not output anything to the browser. Here's where we output it to the browser. When we say print tr, td, so we're making a table row with a td, and we're putting in the first td the value of n, td, and start td, putting in the value of s, and then we're closing our td tag. So that's all these things that get produced. 100 of them. TR, TD, the value of n, TD, again, the value of s, and then an NTR. PHP has what's called magic quotes. And it seems that PHP magic quotes in newer versions of the language are no longer used. So if you run this example and it doesn't work, you have to manually concatenate those fields together. I'll show you what I mean by that. All right. These are called magic quotes because the server is smart enough to put, instead of actually outputting the value of $n, is outputting the value of this variable. And likewise, instead of putting out the value of $s, it's outputting that variable. It actually might be an option. I haven't researched this enough. I was troubleshooting with a student in one of my Akron classes, their problem, and it seemed like magic quotes weren't working the same way or something. But anyhow, if you do not, magic quotes don't work for you, then do this. The dot means concatenate. So I'm going to take this string and concatenate the value of n. Then I'm going to take this string and concatenate the value of s. And then I'm going to take the finished last part of the string. This should do the same thing as the magic quotes. Again, the location of these files is protected, so I have to respond that way. If I do this again, it shows me this. Same thing. So that's the basics of how PHP gets run on the server and produces HTML that gets sent back to the browser. What if I have a mistake? I forgot the dot, let's say. What's going to happen? Well, I'm going to get an error message. Or maybe I get something cryptic like this. Page isn't working. That doesn't really tell us much information. It just tells us that there's some kind of error on the page. You can actually get more descriptive error messages by editing a file called the PHP ini file. And that file can be found here. Let me search for it. It's in this folder, and you can search for it on your machine. And I'm going to edit it. And I'm going to look for errors. This is showing you what all these things mean. And again, it's worth reading. I'm going to jump to the thing that we need to change. Okay. Display errors. Display errors is set to off. That means it's not going to show you exactly what's wrong. Well, what good is that, to have an error and not being told what exactly is wrong? If a website is in production, you do not want to divulge to the outside world issues about and errors that your PHP pages have. Those errors can be used by hackers to gain information to exploit the system. So therefore, we're not going to display any errors when it's in production. However, when we're in development, we want to set this to on. So I'm going to set this to on, save it. And now, when I view this page, I get an error. And it tells me parse error, unexpected variable, $n. So I know the problem is somewhere around the $n. And hopefully you'll be able to look at that and say, oh, there needs to be a dot between this string and the value of the variable. And away you go. Now, in this case, I have HTML, a block of PHP, and then more HTML. You can actually intersperse PHP throughout your HTML file. So there's different ways that you can mix your PHP with HTML. And the second example does the same thing as the first example did, except it's written differently. He gets the same result, but it's written differently. Different pieces of it. So in this case, the for loop is in PHP. The end of the for loop is way down here. And this is plain HTML. This is printing out the value of the variable n. This is plain HTML. This is printing out the value of n. So I've just mixed the PHP and the HTML differently. It doesn't matter to me which one you use, which technique you use. You can mix your HTML and PHP any way that you want. The difference, of course, is when you do it this way, we're just writing HTML. And you're interspersing where values from PHP fill in the blanks and where there's loops and if statements and so on. In the other way, you're going to have within your PHP block outputting HTML using the echo or print statement. So either code your HTML as HTML and mix your PHP in this way, or do it this way. All right. Your main goal for this week, because let's see. Your first homework assignment is due April 5th. And that's to create a Mad Lib in PHP. So the first thing that you should do this week is make sure that you can install PHP. All right, and I have a video here about XAMPP.
Short video showing.
All right, and you can watch that. So your main goal is to watch that and get PHP installed on your machine. How do you know if PHP works? Again, type localhost in your browser. Take these examples and move them into your web server root directory and make sure that they run. All right. Now, a lot of server-side scripting involves interacting with forms, right? You go into Canvas, you log on, you enter your personal data, your credentials through a form. All right. That form, the data from that form gets sent to the server. Not that Canvas is written in PHP. I don't know what Canvas is written in, but it's written in a server-side language. The server-side script, whatever it's written in, takes that form data and verifies that you're a legal user or that you're not a legal user. Google search. When you go to Google and you type in your term that you're searching for and hit search, you get search results based on what you entered in the form. So an important aspect of server-side script of any kind is to be able to handle what comes to the server as part of the form. And that's what this example shows us. In this example, we have a form where we enter the upper limit, or I forget what we enter. Let's just see. File is form.php. We enter a starting value and an ending value. So I can go from 2 to 20. And my page output only gives us the values 2 to 20. I enter different numbers, it gives me that range. So this second script takes the values from the form and does something with them. And that's what your first assignment in PHP is to do. You're to create a Mad Lib where you're going to output some text and you're going to fill in the blanks in the text with values that you've entered in an HTML form. Now, if I'm doing a project in PHP, I'm going to do everything in PHP. So this form it says it's form.php, but actually the only thing in it is plain HTML. But that's okay, right? A PHP document can contain any mix of PHP and HTML, along with JavaScript and CSS. Oh, you can make a PHP page that doesn't have any HTML. What are the advantages of doing it that way and not just calling it HTML? Well, the advantage is that at some point, maybe you do want to put some PHP code in here. And you don't have to go back and change links and change files and so on if I wanted to add some PHP code here. All right, let's look at the form and look at the server code and review how this transaction works and maybe even draw a picture of it. So let's open this one up. And let's draw a picture to give you an overview of it. Client, internet, server. First thing that happens is the client is going to request form.php. That's going to go through the internet and form.php turned into HTML is going to get delivered to the client. So the client is looking at that page converted to HTML. The client enters data in. That data goes through the internet as part of a request. So we're gonna call first3.php, and we're gonna pass the data that was entered in the form. That's gonna go to the server, and that's gonna come back as first3.php converted to HTML using the data from the form. All right. Client's going to ask for form.php. That gets sent to the client, converted to PHP. The user is going to fill in the form and press the submit button. Pressing the submit button is going to call first3.php, and it's going to pass the data on the query string. That data gets to the server. That code in first PHP is going to pull that data from query string, use it to create the web page, and then deliver back first PHP converted into HTML using the data from the form. So let's see how that works in practice. So I'm going to request form.php. Straightforward enough, right? Because form.php is just plain old HTML. So we have an HTML form. We have a text field labeled start. We have a text field labeled end. We have the appropriate labels for those. Why do we need IDs and names? The name is what the web server is going to use to identify that data. The ID is typically used when you create a label, and you can use that also in CSS and JavaScript. So I have a form with two text fields, one called start, one called end, and then I have a submit button. What does the submit button do? It sends another request to the server. What does that request look like? That request looks like this. It's going to go, first of all, to this page. So when I press the submit button, I'm going to first3.php. What does the word get mean? The word get means it's going to transfer all these values on the query string. So all of my form controls that's part of this form are going to get sent to the server, specifically to this script called first3.php, and it's going to be on the query string. And it's going to be on the query string where it's going to say the name equals whatever the value is. So I type in, let's say, 5 to 500. I press submit. What gets called? This gets called. Hope you can see that. There we go. We're on the same server. The action or the action of the form was this, first3.php. That comes from the action of the form. The method on the form says we're going to pass this data on the query string. This is the name of the first text box equals the first value that was the value that was in the first text box. We have an ampersand then. Name of the second text box equals the value that was in that text box, ampersand submit, which was the button that we pressed that had a name of submit, equals process. That was the value of the button. So this is where everything comes from. Try to put these up on the same at the same time so that we can see them. Action, action. How do I know it's on localhost? Because there's nothing before it. If there's nothing before it, it assumes the same web server and the same directory. So that's how it knows it's localhost first3.php. The method is get, so we're going to put the data on the query string. The name of this form field equals the value that was in that text box. And if you remember, I put 5 in it. The name of this field, and, is going to put the one that was in the second text box, which if you remember is 500. Finally, since we clicked the submit button, the submit button has a value of process. This allows us to know which button got clicked if you have a web page that has multiple buttons. For example, you could have a page that brings up data that you could either delete or update. Well, if you click the delete button, it deletes it. If you click the update button, it updates it. The server will know which button got pressed because it will get passed to the second page. Which button got pressed. Now, I'm using get because get puts it on the query string. The other option is post. And we'll probably look at some examples of posts later on in the semester. The difference is that we won't see on the query string. We won't see as part of the URL the data that gets passed, which means that, like, say if we're passing a password, we wouldn't want to pass that on the query string because that would be visible. We would want to pass it using the forms collection, which is what post said. But we're not going to worry about that right now. Right now, we're just going to worry about get, which is going to pass the data on the query string. All right, so what does first do with this data? First 3. Well, HTML gets sent to the browser, exactly as it is. I set my variable start equals request start. All right. Where does request come from? That's part as what's called a global PHP variable, which means it's available. This means data that was sent over as part of the request of this page. In our case, the data that was sent via the query string. This is what particular value we want from the query string. So if you notice here, we want the value of start. So it's going to fill that variable with the value 5. So the variable $start is going to have a 5 in it. This is going to have a 500 in it. And then we do our loop as before, except we don't have hard-coded values of like 1 to 100. We say start the value at whatever this value is, and the value at whatever this is. And it will go square it and output the results, and we're in business. So we get 5 to 500. Let me quickly show you how this would work if I change this to post. It should still work. All right, it works because request says wherever it is on, however that data was passed. There's also a post and get. So I could do post when the method was post and get when the method was get. Or I can just do $response and it will find it either of the two places. Notice when I call this way with post, that data isn't on the query string. It's more useful for debugging purposes if we see exactly what's on the query string. So to start out, we're going to do all our requests using get, at least for now. So we can see exactly what got passed to the second page. Now, what happens if we put goofy data in? What if we type in starting value is 100, ending value is 1? How do we explain that? Well, start got to be 100, end got to be 1. We're going to start n at 100. We're going to go as long as n is less than or equal to 1, and we're going to add 1 to n each time. Well, right off the bat, n is not less than or equal to end, which is 1. Therefore, we don't do this loop at all. And we just get an empty table. What happens if I type in even goofier data? Same thing, which is weird. You might expect us to get an error. All right. Unfortunately, we don't. Why do I say unfortunately? Do I like errors? Well, I like errors when there's something that's wrong so I can figure out what's wrong and fix it. PHP is called a weakly typed language. And what that means is we don't declare variables as being of certain types. In fact, we don't declare variables at all, or we don't have to declare variables at all. It's going to pull values start and end from here. Then it's going to try to do this, and it's going to guess if there's invalid data. Like if start is not a number, it's going to assume, well, it must be a 0 then. And this must be a 0. And it's not going to work. I don't know if I should correct myself. It's going to try to do this, but it's not going to get any result. That makes sense. So it produces an empty table. So we're going to have to validate. All right, we're going to have to validate. Now, where do we validate? We have a choice of where we validate. We can validate on this page using JavaScript. Right? Why JavaScript? Because we want to do something to a page that was already created. So therefore, when that button gets clicked, we don't want to immediately submit the data. We want to validate it first. All right? So we're going to put validation here to make sure that starting value is less than ending value and that these two values are both numeric. We're not going to do that today, but were we doing this, if we had enough time today, we would go and do that. But you know what? We're also going to do it here. We repeat validation both on the client and server side. And that may seem redundant or it might seem like overkill, but it's not. You know, might seem like a guy that wears a pair of suspenders and a belt, right? Like, why do you do both? Well, in this case, you do both because it is possible to circumvent any client-side validation. I could simply turn off JavaScript from my browser. Okay? That's one of the settings somewhere in here. If I look for settings, I'm not sure exactly where it is. But someone trying to circumvent validation either innocently or someone that is trying to disable JavaScript either innocently or maliciously could try to circumvent validation and disable JavaScript and get around any validation that the client side has. In which case you have validation on the server as a backup. Why not just put the validation in the server side then, if we're going to have to put it in anyhow? Well, because the client side gives us errors immediately and doesn't require any resources on the server. Remember, code that exists within a web page that gets run happens instantaneously. Code that happens and runs on a web server takes some work to produce. Might not be obvious in our case because, you know, we're on the same machine and the processing goes virtually instantly anyhow. But it actually will happen quicker on the client side. There's another reason for this. And let's think of something maybe in an actual application of validating a credit card number. Now, I can put client-side validation to validate a credit card number. All right. I can make sure that the number entered is numeric. I can make sure that the card number entered is the right number of digits. But I cannot on the client side check with the bank and make sure that that's a valid credit card number. The client side doesn't have the resources to do that. So I can do some validation on the client side, validating that the data looks like it could be valid, but the actual complete validation of validating that that indeed is a valid credit card number, the account hasn't been closed, the account isn't past its limit, the account hasn't expired, the 3-digit code I typed in is correct, the name and zip code is correct. That validation has to happen on the server because only the server has the resources to do that sort of validation. So the bottom line is we're going to do validation both on the client side and the server side. The client side gives us speed and convenience to the user and doesn't require any server resources. But it can be circumvented and it will not be complete in some cases. The server side, however, will do complete validation, validating everything the client did, plus maybe more, like making sure it's a valid credit card number and so on. So that'll be one of the things that we look at next week is validation and how to do validation client side and probably talk about server side as well. So here's your task. Get PHP running on your machine. Should be the first thing you should do. Try to get that done this week, even though it's not an assignment to do it this week. How do you know if it works? Run my examples. All right, and see if my examples work. Then try to work on lab 8, where you create a Mad Lib. How's your Mad Lib going to work? Well, you're going to have an HTML form that you enter in the data. then you're going to have a PHP page that's going to take your story and insert the values of variables that you pull from the form, from the query string. If you get that done, I would suggest you look at some of these examples. Example B, along with these two validations. We'll try to do these three things next week in lecture. Are there any questions? If not, that's all I had today. I'm going to be heading up to lab if anyone wants to join me up there, either in person or virtual. And if not, we'll see you next week.